Hi, good morning, all of you. I hope all of you are doing well. 21 days lockdown is really a very big task, a very good move by our Honorable Prime Minister Shri Narendra Modi. And I'm sure all of us will cooperate in the initiative taken by the central government to fight the epidemic that has actually created a panic across the country. So I'm just taking this opportunity not to waste our time and try to see if something can be done by sitting at our place of stay and let us try to see something that can be done in the field of operation research. Before we went on the break, we had exposed ourselves to introduction to operation research, and then we have seen linear programming problems. We have seen how linear programming problems can be solved using graphical method where there was a restriction in terms of the number of decision variables, and then when decision variables started increasing, we exposed ourselves to one of the most efficient algorithm to solve linear programming problems, what we call it as simplex method. And then in simplex method also we have exposed to problems which involves all the three types of constraints, equality constraints and both the types of inequality constraints. Now let us move forward and try to see the next module. Here we will expose ourselves to the fourth module, which basically consists of two different models of OR. One is called as transportation problem and another one is called as assignment problem. In fact, majority of them they discuss transportation problem before they move on to the assignment problem, but I have a different approach. I personally feel that we should first get ourselves acquainted with what is called as assignment model, and then we can proceed for transportation model. And hence what we are going to do is we are going to expose ourselves to assignment model. Now basically we know that the simplex techniques are used for solving linear programming problems. However, there are some special cases of linear programming problems whose solutions can be obtained by different techniques. They are either easier to apply and greatly reduce the computational work required by the simplex algorithm. Two such techniques are called as assignment and transportation problem. Now this particular topic deals with one such special case, what is called as assignment problem, which finds its own applications in allocation, scheduling, assigning salesmen to different regions, vehicles to different drivers, vehicles to different routes, products to factories, contracts to bidders, and research problems to teams, and variety such real-time applications. Assignment is generally made on one-to-one basis, and if there are more jobs to do that can be done, one can decide which job to leave or what resource to add. Now, basically what we are going to cover in this particular topic is these things. We'll just have an introduction to the assignment problem. We discuss the mathematical formulation. The most popularly and efficient algorithm to solve all assignment problems in the field of OR is what is called as Hungarian method. And then we'll see variations in assignment problem before we look on to the last application of assignment problem, that is called as traveling salesman problem, which otherwise you would have done in design and analysis of algorithms, wherein you have studied how to solve TSP problems using various design techniques. Of course, if time permits, we will discuss the crew scheduling problem as such, it is not there in your syllabus, but let us see if we can do some justice to that particular application. Now, a simple introduction to assignment problem is this particular model or this particular group comprises problems concerning as to what happens when we associate each of the number of origins with same number of destinations. So the basic objective is to assign the number of origins to equal number of destinations, either at minimum cost or maximum profit. Now one of the simple example I always discuss when we discuss the assignment problem is your subject allotment in your classes. Now say for example, when you talk about your own section, you have, let us say you have 6 subjects, and when you look at the total number of faculty members in the department, you have 30 faculty members. Now look at this, it's so interesting that only 6 faculty members comes to your section to take 6 subjects. That means each subject is handled by one faculty member. Now, one faculty member, there is no faculty who handles more than one subject, or it is also possible that a particular subject is not handled by two faculties. So what we do in assignment problem is we ensure that at the end of the day, the number of subjects are equal to the number of faculties that are assigned, and thus we have 6 number of faculties taking 6 number of subjects. Now look at the faculties end. As I told you, you have 30 faculties, for example, and only 6 faculties are handling it. That means 24 faculties are not taking any subject for your section. And this is what I said in my introduction part, that if there are more jobs to be done, one can decide which job to leave undone. That is, I can decide which faculty member should be dropped out from taking the class for your section. Now the allotment of the faculties to the subject should be done in such a way that the teaching learning methodology, the teaching learning process should be a rewarding experience for both faculty as well as students. Now moving to the mathematical formulation of this assignment problem, by default, as we know that all of our models talk about minimization. So you have the summation of these two, you have the objective function called as z, and you have summation of I is equal to 1 to n and j is equal to 1 to n from xij, cij, which is a part of the objective function, where the values of I and j both range from 1 to n. But there are certain restrictions, because you know that OR always tries to give you optimal solution based on so many restrictions. And the restrictions that you have in assignment model is xij will be 1 if ith person is assigned to jth job, otherwise xij will be 0 for all other values of I and j. Now the entire assignment model is actually represented in the form of a matrix, what we call it as cost effectiveness matrix. Now whenever you are asked to solve assignment problems, you will be given a matrix for you in most of the cases, whereas in some cases you need to basically formulate the matrix on your own by carefully understanding the problem statement, and then once the matrix is with you, what we call it as cost effectiveness matrix, you can proceed trying to find the optimal solution by using the Hungarian algorithm. Now let us understand what is all this cost effectiveness matrix all about. Now on one hand I have given something called as number of persons, and on other hand I have something called as jobs. Now in this what happens is we have a person number 1, and then you have a couple of jobs here, right? Let us say job 1, job 2, job 3 up to job n. Now basically what happens at the end of the day, person number 1 will do only one job, but which job he is going to do we are not aware at the beginning. So we represent everything in the form of a cost effectiveness matrix. What does it say? Have a look at this C11. This C11 signifies that if a person 1 does job 1, then the total cost involved will be C11. Similarly, if person 2 does job 1, then the total cost involved will be 2121, that is C21. Similarly, I have n here, and the cost will involved in doing the nth job is Cnn. Now this particular entire matrix will be given to you, which will be filled with integer numbers. So you don't need to worry about this. Say for example, if I give you 5 here in place of C11, the significance of that 5 is if a person 1 does job 1, the total cost involved will be 5 rupees. So this is what is called as cost effectiveness matrix. As such, it is said that linear programming problem is a vast area which is in the field of operation research. And under linear programming, we have something called as assignment model, which is actually a special case of transportation problem, right? Now, what is it? It is thus a special case of transportation problem where supply of each of the resources and demand at each of the destination is taken to be unity. That is what I said, one teacher will end up taking one subject. It is due to this fact that assignments are made on one-on-one basis. In this case, people possess varying abilities for performing different jobs, and therefore the cost of performing the jobs by different people are different. Let us have a look at few applications where assignment model or assignment algorithms are used in real life. Something called as assigning vehicles to routes, scheduling teachers to classes, assign salespeople to sales territories, assign development engineers to several construction sites, and many more such applications. Now, before we proceed with how exactly to solve the assignment problem using Hungarian algorithm, let me share with you some of my publications, some of my work in the field of operation research, exclusively targeting assignment model actually. So I'm not going to discuss or give a brief about this. I'll just spend some time. I'll give you some time, just go through this particular slide. Okay, so they were some of my publications exclusively related to assignment model. Now let us look into the algorithm that's available in the field of OR to solve assignment problems, what we call it as Hungarian method. The Hungarian method is a combinatorial optimization algorithm that solves the assignment problem in polynomial time and which anticipated later primal dual methods. It was developed and published in 1955 by a person whose name was Karold Kuhn, who gave the name Hungarian method because the algorithm was largely based on the earlier work of two Hungarian mathematicians, Denis Konig and Gino Igerveri. Now this is how the algorithm looks like. At first instance, you may not be in a position to understand unless somebody explains you. You will get a PDF version of this algorithm to your inbox directly. So just to go through it for a few seconds, and then we'll come back to see how problems in this can be solved. So when my sincere suggestion would be when I make an attempt to solve the problems over a period of time now, after some time, you can keep the PDF version of this step-by-step approach of Hungarian method, so that when we are trying to solve the problem, things will become much more easier for all of you.